before we start, I wanted to show one of the questions that we asked you when you registered was, what is your favorite marine or freshwater animal? And this is just to contextualize what we're talking about with plastic pollution, because it is harming marine life. Now, I wanted to show you all what the answers look like. So there was no surprise here. The main animal of everyone's favorite is the dolphin, happy dolphin. But whales featured prominently, and turtles as well. Now, all of these, all marine life is affected by plastic pollution, sadly. But I thought we could just celebrate a few, and I wanted to pick up some of the more interesting ones that that you have nominated. One of you, Ben, from the UK, I don't know if you're online yet, as it's early in the UK. Ben's favorite marine animal is the robust ghost pipefish. So I thought I'd play a little video of the ghost pipefish. What you can see is this small fish that looks like seagrass, which I suppose is a mechanism to make it look a little bit less tasty to predators. Now, we actually do have a marine biologist amongst the presenters, although she'll be very humble about that. So Lauren Bierman from Plymouth Marine Lab, who's one of our remote sensing specialists. Lauren, if you could unmute yourself, I just wanted to check with you. Are the robust ghost pipefish affected by plastic pollution?
I'm just watching this video, first of all, to say that they're absolutely beautiful. I've never seen one of these on a dive, but I now have a new obsession, I guess. But yes, at all levels of the marine ecosystem and food web, we are seeing that microplastics and macroplastics are having an impact. Even with these absolutely hypnotizing fish, they would be affected by microplastics. And perhaps even macroplastics. So with every sort of name that is on the screen that you shared, from dolphins to turtles to nudibranchs to ghostfish, unfortunately, the answer is yes.
Oh, they're so tiny. I'm not sure which end the mouth is, but I guess it's more affected by the smaller or the microplastics.
Yeah.
Now, on to the next one you already mentioned. So Nilam Sari from Indonesia. I think I've seen Nilam in the participants that are online now. The favorite marine animal was the nudibranch, which I'd never heard of, actually. I'll skip through to here. But what I did learn is that it's a very bright sea slug, bright colored, and strangely, the gills are on the outside. So sort of like having your lungs on the outside of your body, which is quite beautiful. So Lauren, it's a sea slug. I'm not sure. Is it also impacted by plastic pollution?
Yep, it will be. So it feeds on small things along the substrate, and there's microplastics inside of animals much smaller than nudibranchs. So nudibranchs, I don't know if you have ever, you said you weren't aware of them, but I go bananas when I spot them when I'm diving, because they can be as small as your pinky, and they're quite difficult to spot sometimes. But animals even smaller than that nudibranch are even shown to ingest microplastics. And then things like the zooplankton then become ingested along the marine food web. So yes, inevitably, even these beautiful, brightly colored sea slugs that are so gorgeous and unique will be affected by plastic pollution.
Okay, but what about if we go into the deep sea? Let's see. Now, this is my favorite marine animal, the glass octopus, but it's only found in the deep sea. So it's not near the surface where we're throwing the plastic in the water. It's very, very deep. And you can see probably why it's my favorite. It's very beautiful, it's translucent. You can see all the organs straight through. But what about deep in the ocean? Is it still affected by
Yeah,
plastic?
so even within the Mariana Trench, which is one of the deepest places that we know about in the ocean, we've actually sent submersibles, and video footage there has shown that our rubbish has made it even as deep as the Mariana Trench. And marine snow might also be affecting this, but also remember, a glass octopus itself doesn't need to go pick up a plastic bottle and put it in its mouth. It's eating the fish that have eaten the zooplankton that have eaten the microplastics. And so that bioaccumulates throughout the marine food web. And so without thinking about it or knowingly doing it, that glass octopus is going to be ingesting animals that might have microplastics inside their bodies. And in fact, it's even reaching human beings through a similar process because it's inside of our inside of our salt, it's inside of our water. It's kind of inescapable, even if you're a beautiful glass octopus in the depths of the ocean.
Okay, very sad, but thank you very much. So I will pause there for now. So we'll hear more from Lauren later. She's going to teach us about how to go hunting for plastic pollution from space. So from the Mariana Trench up into space. So, so without further ado, I'm going to start the formal agenda of the workshop now. Anytime you have any questions throughout the workshop, you can pop it in the chat and we'll try to directly answer it, or you can also even send a private message by chat if you would like. So to kick us off, we've got 2 words of welcome from 2 very special speakers. Firstly, we have Mr. Takayuki Shigematsu. He's from the Ministry of Environment in Japan. And the reason we've invited Takayuki to provide an opening is we'd like to share what that international policy dialogue and commitments, what does that actually look like? How have countries really decided to come together to take action to prevent plastic pollution at that global scale? So without further ado, let me hand over to Takayuki. Thank you.
Yeah, thank you, Janet, for introduction, and thank you so much for inviting me for this wonderful workshop. My name is Takayuki Shigematsu, Deputy Director for Office of Policies Against Marine Plastic Litter, Ministry of the Environment, Government of Japan. I would like to show my deepest appreciation to the members who participated in today's online event, measure, monitor, manage innovative approaches to evidence-based plastic pollution prevention. Also, I would like to show my deepest appreciation to ESCAP for organizing this online event, collaborating with the Plymouth Marine Laboratory, United Kingdom, Institute of Global Environmental Strategies, IGES, and Wageningen University and Vietnam National University. At this time, I would like to provide a few opening remarks. As we are aware, marine plastic litter problem is regarded as a serious universal problem at global scale, and many nations and areas already undertook measures to solve this problem. In this regard, I'm grateful that the Osaka Blue Ocean Vision that aims to reduce additional pollution by marine plastic litter to zero by 2050, which was shared at the G20 Osaka Summit in 2019, is now shared by 87 nations and areas, including Asian countries, reaching out half the world. Japan also initiated the establishment of G20 implementation framework to share knowledge and experience. Last month, the 3rd G20 report on action against marine plastic litter was published under the G20 Italian presidency with the kind cooperation from the 35 countries and 12 organizations. In order to support such initiative region, including ASEAN nation, Japan has been promoting various cooperations such as capacity development, waste management, and marine monitoring based on action plan of each countries. And the initiative like the ASEAN Summit in 2018. I believe this webinar will share policies and progress efforts of private sectors of each country, as well as the research institute, and also to share importance of policies-based latest scientific knowledge in order to accelerate capacity development regarding reduction of marine plastic litter and waste management. For example, Regional Knowledge Center for Marine Plastic Debris, which was established in October 2019 under AREA, will work as a network and knowledge gathering hub. It will provide policies for each country's and scientific knowledge, as well as best practice for private sectors to tackle the marine plastic litter issue. Japan will promote contributions to some countries, including Asian nations, for setting up guidelines to compare different monitoring data gathered with a different method, providing training to improve monitoring technology of each country, field research, and manual preparation support, or etc. Let me give some example regarding the monitoring or research. We have published the guidelines that will make it possible to compare monitoring data whose results cannot currently be compared due to the different methods. In addition, in order to improve the technical capacity of monitoring in each country, we are planning to provide monitoring training, joint field surveys, and support creating manuals to some Asian countries. At this workshop, I would like you to think about how science can contribute to solving the world's common challenge of making ocean clean and sustainable. To that end, it is necessary to bring together our strengths of each country or institute. This workshop will be an important venue for building such a network. I strongly hope that discussion at this workshop will bring us one or two steps closer to solving the problem of marine plastic litter. Thank you so much. That is my opening remarks. And over to you.
Thank you very much, Takayuki, for sharing what's happening at that international level. And in case anyone's thinking, why don't they do something about this problem? But there is a lot of activity at that international level to cooperate. It's something that's very difficult for one country to address on its own. So we do need all countries to work together. And myself working in the UN multilateral space, I can tell you it's a lot easier to cooperate once we have these international frameworks so that we can speak the same languages. We can try to work together to achieve common goals, and we overlap a lot less when there is an international policy framework. So we very much appreciate this work and the leadership of Japan on this. Now, that's what's happening at that global level. But what if you're an individual or a group of individuals that wants to take action? And this is where we're going to hear from Malati Wisjan. She's one of the co-founders of Bye Bye Plastic Bags, made famous with their TED Talks and multiple speaking at multiple events. She's also the voice of our video series on monitoring, measuring, and managing plastic pollution. And she's just come back from the Cannes Film Festival, where she's launched her own film about being a change maker. Malati and her friends took action as high schoolers in Bali, where they saw plastic pollution with their own eyes. They may not have had the numbers, they may not have had the monitoring systems, so they just had to use their own eyes, and they took action, which led to the phase out of the use of plastic bags in Bali. So we're going to hear from Malati from her perspective, why it's important to measure, monitor, and finally manage plastic pollution. So over to you, Malati.
Thank you so much, Janet. And hello, everybody. Good morning from here in Holland, where I'm currently at. Usually, I would be joining in from Bali, Indonesia, which is my home. Hello. And I'm more than excited to share a little bit about my story as a young change maker with all of you, and how and why I believe we all have a responsibility to be part of the solution. But before I go into that, I think it's really important. I know we're all, it's the beginning of a great 3-hour workshop, so we're already looking at our screens for quite some time. So I encourage all of you to sit straight, fix your posture, roll your shoulders back, and on the count of 3, join me in taking a nice deep breath in. 1, 2, 3. Take a deep breath in and out. And one more time, another deep breath in and out. I like to do this on any occasion, any event, any stage, because it, 1, lets the butterflies in the stomach settle, ground myself before a speech. But the second reason is why I really do it, and it's because it proves as a strong reminder that 70% of the oxygen we breathe comes from the ocean. That means almost every second breath is coming from the ocean. And I grew up on the island of Bali, part of Indonesia, the world's largest archipelago with over 17,000 islands with only ocean surrounding us. So at a young age, growing up on the island of Bali with rice fields, beautiful beaches, mountains, we had the natural world all around us. And it wasn't rocket science to start seeing that plastic pollution was everywhere. I mean, as Janet said, we didn't have necessarily the tools that it took to monitor or measure or manage, but we did have our eyes. And even at the age of 10 and 12 years old, when we first started on our adventure of bye-bye plastic bags, we simply knew we could not wait until we were older to start making a difference. And so at the time, one thing that we did have was the internet. And we learned quickly from looking and researching that 40 countries already at that time in 2013 had banned single-use plastic bags. And that we thought was something tangible. We thought if they can do it, come on Bali, we can do it too. And we've since then mobilized one of the largest youth-led movements in the country to host workshops, focus on education, because we know just how important it is. If we change mindset, if we change heart set, we'll be able to actually implement the changes we want to see. But one thing we were missing, one thing we felt we were missing was the numbers. And I think also throughout my experience now for the last 8 years on the front lines, every government meeting I attend, every company meeting I attend with CEOs, general managers, politicians, one of the biggest barriers that prevents them from change is oftentimes this excuse that there's still so much research still needs to be done. I agree. But going back to being 10 and 12 years old, we could see that it was not rocket science, that the plastic pollution was growing. And if we don't do something now, we're heading towards a future we will not be proud of. And so that is where I think the role of young people really kicks in to say, hey, yes, a lot of research still needs to be done. Yes, we still have to learn a lot about alternatives and implement new solutions, but that has to start today. And that's where a lot of the urgencies come from our generation. Leading by example comes from a lot of grassroots leaders and communities where we have to understand all of those different pinpoints. But the importance of those numbers comes through monitoring, comes through measuring from the very start. And I remember learning for the first time citizen science, and having those forms or those surveys after a cleanup, for example, that you had the power as an individual to collect that data and submit it into a portal where then at a large scale, this would all be collected and shared in a report. A really good example in Bali is from an organization called Sungai Watch, a river cleanup organization. And you will see a video soon where one of the best ways to monitor and manage and measure the plastic entering the ocean is if we cut it off at the rivers. So Sungai Watch in Bali collects and protects over 80 rivers on the island. And what they do once they collect this waste is sorting it, washing it, collecting the data. And what they do is publishing this in a river report accessible to everyone. And I think that once we have this data, we can start the dialogues with companies, with plastic producers. And this is something that I've really learned as a young change maker, that this is necessary in order to step into a room, to have this information with you, to show and to prove that, hey, we don't only see it, but here are the numbers to prove it. And it's a missing language that we still need to normalize, and we still need to make a norm, that we're actually listening to the science, listening to the facts to base our decisions of regulation. So I know I'm talking a lot. I've passed my 5 minutes by far, but I hope that my last message for all of you of inspiration is in all of your positions to make sure that you invite and include young people, because we will accelerate change. We will continue to hold accountability at the center of everything we do. And we know that the urgency for time, there is no better time to change than right now. So with that, I'm going to pass it back to Janet, and or show a video of a series of Closing the Loop that we collaborated on together with ESCAP.
Wonderful. Thank you so much, Malati. Especially love the breathing in and out at the start, which sort of reminded me that we also breathe in microplastics in the air. So, you know, this is a really urgent issue for everyone, including our health. And really congratulations to the amazing impacts that you've had, despite being young, despite not having data, you know, against all odds, you've made it. And we want to support others like you around the world, and hopefully get more policy frameworks in place, more data out there about the issue, and more monitoring to check that we're actually reaching our goals of ending plastic pollution, as Takayuki mentioned, is the global policy goal that we've all committed to. So without further ado, again, thank you so much, Malati, for joining us and giving that inspiration. Now we're going to hear her voice in our first animated video, which is only about measuring. So we've got 3 strategies to end plastic pollution. One is to measure it, one is to monitor it, 2 different things, and the third is to manage it. So Abigail, I'll hand over to you for the playing of the video. Thank you.
Plastic waste is entering our oceans at a staggering rate of 11 million tons a year. And if we don't take action, there could be more plastic than fish by 2050. To stop the plastic entering the oceans, we need to find where it's coming from. This begins by measuring how and where plastic waste is generated. And it's different for every city. The people, their neighborhoods, and places they work are all factors, along with tourism, festivals, and events. Managing all this waste is a huge operation. From recycling centers, waste treatment, and fleets of garbage trucks, to individual street sweepers and informal waste collectors. Understanding every stage of the process is how you spot where plastic is leaking out into the environment. It could be overflowing bins, inefficient transport, or poor storage at landfills. Flushed waste and illegal dumping are also to blame. Once plastic waste leaves the management cycle, it's just a matter of time until it reaches the ocean, whether flowing through storm drains, picked up by the wind and blown into rivers, or washed off the land during heavy rain. By measuring the data routinely collected by waste management operations and researchers on the ground, it can be added to a pollution calculator, so you can measure what kinds of plastic are accumulating and pinpoint the plastic leakage hotspots, so you can apply fixes to keep it out of marine environments.
Okay, great. So that's our short video on measuring plastic pollution. Thank you again, Malati, for sharing that. By the way, she's just got a new film out, so make sure to check that out. So we're going to now move on with the presentations. Again, any questions, just pop them in the chat and we'll try to send more info out to you. So now I have the floor. Let me, and what I'm going to do is talk about the closing the loop approach to plastic pollution prevention. Okay. If I can manage to share my screen. Okay. Is this the right screen?
No, that's the presentation screen, Janet. Yeah.
Okay, yeah. Start share. Okay. All right, now I've got it. Thank you very much, Zoom. Okay, hopefully this is the right one. So I'll share what we've our findings and our approaches. So the Closing the Loop project, it's a project run by the UN, and we're working in the ASEAN region, and we're focusing specifically on cities that are close to or on the coasts. We have 4 pilot cities: Kuala Lumpur, a great capital city of Malaysia, We have Da Nang, which is more of an ICT ready city, so we can test out a lot of the digital solutions there. Surabaya in Indonesia, which is already known for innovation around plastic waste management, and Nakhon Si Thammarat, down here, a smaller city on the coast of Thailand, with a lot of canals and a large plastic problem. So what do we want to achieve there? Well, we have two objectives. One is the numbers side, and that's where our objective is to measure and then monitor the plastic. And that we advocate using innovation and smart technology to achieve that. The second thing is then, once we have that information, is to manage the plastic. And by that, we mean preventing the plastic pollution from entering into the water. And the way we do that is by working with the cities to develop the policy and investment strategies to apply the circular economy approaches on measuring and managing plastic. Once we've done the measurement and the monitoring of the plastic, it actually becomes very straightforward to know what actually needs to be done to tackle the problem. So if you're thinking about what you can do in your country or city, I just want to share our approach in a little bit more detail of those 3 steps. Now, firstly, it's the measuring. Measuring plastic waste, understanding what is the source of plastic pollution. It's about answering questions like which products are actually ending up as plastic pollution, and where the leakage points are. Now, leakage points can either be geographic leakage points, so a certain district or a certain point of a river, or they can be a point in the plastic waste management chain. So maybe there is no plastic collection, plastic waste collection, and so the waste just gets dumped directly into the environment. Or maybe there is collection, but the plastic got washed away before it was picked up. Or maybe the bins were overfilled and it overflowed. Or maybe it did get picked up from the bin and it came out of the truck. Or maybe it made it all the way to the landfill, but then during a monsoon, it got flushed out back into the environment. So knowing where those points are is really critical, because obviously when you come to your action plan later, you can plug those gaps. But what's also really important is the qualitative side of plastic pollution. So knowing what those policy and institutional environments are. So in the cities we've worked with, it's about understanding, well, what were the national goals? We've seen a lot of national policies around plastic prevention, but how are they linking to the city level where the actual waste management occurs and is mandated and budgeted at? Or are there waste management policies within that city that could be strengthened with regards to plastic waste prevention? Particularly when it comes to recycling, what you often find is that a lot of the recycling is done by the informal sector. So looking at ways to engage them as important stakeholders and strengthen their activities, maybe complement them with commercial or public sector recycling. Once you've done that, that's quite a big job. So it's something that you can't really do every year. But once you've done that, you actually have a lot of the information already to develop your action plan, and you can go ahead and do that. And so that's the third part here. But what is also important is setting up a monitoring system. So if we think about the bye-bye plastic bags example, they managed to get a ban or phase out of plastic bags in Bali. But what is useful is to see whether that is working. So it's not enough to just have a policy. You need to check that the actual issue, the plastic pollution, is reducing. So under Closing the Loop, we're advocating for digital mapping of plastic pollution, which Lauren and Tim are going to go into in more detail in the next session. So basically, what does that involve? It means collecting a lot of data. The type of data is basically having eyes on the ground or eyes on the water, in the case of rivers and coastlines, to collect images to see those areas using different types of remote sensing like satellites or sensors, cameras, or crowdsourced data. Now, once you collect all that data, you can't really expect people to look at every image and use their own eyes to check whether there's plastic waste. So part of the digital tool involves data processing using machine learning algorithms to detect the plastic. And so that's the use of artificial intelligence. And they're different algorithms depending on whether you're using satellites or whether you're using regular images like cameras, video or photos from cameras. And we use both types of machine learning. And then the data output should be very simple. So what we want to generate with this digital tool is just a map of plastic hotspots. And that way you can see how many big red dots there are on the map of your city. And over time, you want to see those big red dots shrinking in size as a result of your policy. So that should be implemented before the policy starts, so you get a good baseline. Now, when it comes to the city action plans, based on the baseline assessment, you manage to identify your policy intervention priorities. So you might not find out that plastic bags are the priority or that bottles are a priority. You might find that littering is a priority or improved collection might be a priority. And based on that, you can develop a local action plan in consultation with the stakeholders you identified in that first part of the baseline assessment, as well as an investment strategy, because a lot of this involves money. But then again, collecting and managing waste also involves money. Another important part of prevention is training. So we have a full e-learning course that's free of charge that goes through each of these steps in a little bit more detail. You'll see Lauren and Tim, Miho from IGES, who's presenting after me. She's also been part of the team to develop it. So she'll go into more detail there. Okay. So I did want to mention that when you do measure, monitor and manage plastic pollution, even in one city, you will probably need a lot of partners. So in the case of Da Nang, Vietnam, we'll hear a presentation about Da Nang later. We have a number of partners. Generally, it's the Department of Natural Resources or Environment or whatever agency is dealing with waste in the city. So in the case of Da Nang, it's DONRE. Then there's us, the international partner. Then you have an expert or knowledge partner. So in our case, it's the Institute for Global Environmental Strategies, and they oversee and ensure that those baseline studies and the support for the action plan is using best available knowledge and techniques. Then we engage a local partner. In the case of Da Nang, it's IUCN, and we're going to hear from Hien from IUCN later. And they have their local knowledge combined with the subject matter expertise. And for the digital tool, we are partnering with Japan Space Systems. So they're the experts in remote sensing and developing the tool. But you see here, there's a lot of different partners that provide input and strategic guidance. We'd like to thank all of them, in particular, the government of Japan that provides a lot of the funding for this type of work. So I'll just highlight the measuring of plastic leakage, which we do using the plastic pollution calculator. So this plastic pollution calculator, we've selected it because it is endorsed by the International Solid Waste Association. So for us, it's very important that we all use similar or compatible methods to calculate plastic pollution. The advantage is that we can compare our results once we go to the work of calculating how much plastic pollution there is. And we worked with the University of Leeds on the actual modeling behind this. But what you see is a visual representation of the data of the calculator. Behind each of these little boxes is a set of data that is used to calculate the final number, which is the plastic transportation to waterways. That's the plastic going into that last mile before it becomes marine litter. So firstly, we check the waste generation, how much plastic waste is produced. And there are a bunch of different data sets that go into that. Then we look at the waste management system. So we measure things like the type of source separation, the type of waste containers, the frequency of collection, how much of it is recycled, and so forth. But we know that not all plastic waste goes into waste management. Some of it is dumped directly into the environment. So we have also metrics to come to some conclusion on how much is dumped. And then from each of these sources, even the waste that is managed, but certainly the waste that is dumped, some of it goes into the environment. And then from what goes into the environment, whether it's on land or through the air or directly into the water, some of it goes into the waterways. And there are also a number of variables that affect the extent to which it goes from the environment into the waterways. Now, once we use this sort of calculator, we come up with some very useful results. So for instance, in the case of Da Nang, we found that of the 100% of plastic waste that is generated, we found that 6% was recycled, actually all by the informal sector. 85% went to landfill, and about 1.3% actually became aquatic debris. Now, that doesn't sound like a lot, but it's actually over 1,000 tons every year, or a few tons every single day. And for quite a small city, that's a large amount of plastic, considering plastic is very, very lightweight. We also found out how does it get there? And we found overwhelmingly it comes from littered waste in areas with insufficient collection systems. So they may even have collection, but it's too infrequent, or they don't have any collection at all. Over down here is another key metric, which is what products ended up going into the water or into the environment. And that's different to the composition of plastic waste that's generated, because some types of plastic waste are really, really great candidates for recycling, such as drink bottles. And therefore, they're much less likely, once they are waste, they're much less likely to enter into pathways to become plastic pollution, particularly since they have a value. But what you end up seeing is the types of plastic products that have a low value and low density, which is the plastic film. Recyclers aren't usually interested in that, so it tends to not be recycled. And they're so lightweight that they're really easy to fly off bins or be washed away by water. And so they're disproportionately represented amongst plastic pollution in the water. Okay. Just a brief overview of the monitoring system. We are using 3 types of remote sensors: satellites, GoPros, and citizen science to collect those images. And then here is a little snapshot of how we are processing the images in an automated way using artificial intelligence. And we're working towards getting these hotspot maps. And then finally, we have the action plans. This is the example of the action plan in Da Nang, which was launched last week, but I'll leave this to Hien to talk about later. Okay, so I'm going to pause there. That was my presentation, and if you have any questions about measuring or monitoring or managing plastic waste, you can pop them in the chat. Okay. So that's the end. So now I would like to introduce Miho Hayashi. She's from the Institute for Global Environmental Strategies, and she's going to present the overview of the e-learning course that you're welcome to register for. It's 15 hours. There's some good stuff in there, and she'll give you a quick rundown of how that works. So without further ado, over to you, Miho.
Thank you very much, Janet. Yes, my name is Miho Hayashi, working for IGS Institute for Global Environment Institute. So today I am going to talk about e-learning course, which has been developed under the Closing the Loop project that Janet has just mentioned about. So let me share the screen first. I'm sorry. Sorry. Abigail, I'm sorry, can you please show from your side if possible? I cannot see it.
Sure, just give me 1 minute.
I'm sorry.
Miho, I'm going to start sharing for you now. Let me know when to go to the next slide.
Okay, thank you very much. Okay, yes, as I just mentioned, so e-learning course has been developed under the Closing the Loop project. And then since Janet already mentioned, and there are so many agencies who helped develop this module. This module has consists of seven modules, and then we have 11 organizations who helped develop this course. So it includes the UNEP, IGES, PML, WIEGO is yes, and then ISWA, International Solid Waste Association, and Japan International Cooperation Agency, JICA, University of Leeds, Keio University in Japan, Wageningen University, Plymouth Marine Laboratory, and the Ocean Conservancy. So, and then also it's led by EU and ESCAP. So we estimate that in order to complete those all 7 modules, it may take 15 hours, but you don't have to necessarily work 15 hours straight. Can you go to the next slide, please? Yes, because it's e-learning course, and then you can use your own laptop or tablet or mobile phone, wherever there is a Wi-Fi or internet connection, you can do that anywhere. So it's very easy, user-friendly learning course. And then basically our target audience is local government officials or practitioners. However, it is also useful and helpful for anybody who is interested in learning plastic pollution or how to combat the marine plastic debris to learn those plastic issues, because it has very scientific knowledge in it, and then very recent information as well. So the purpose, objective of this learning course is to share the latest knowledge and approaches to measuring and managing plastic pollution from land-based sources. So this is why I said that because normally the municipality is the one who is responsible for the municipal solid waste management. This is why this course is for mainly municipal officials. But again, it's not limited to those people. Anybody who is interested in learning, they can join. So let me show briefly how it looks like. Abigail, can you close first? And I will share the other one. So the course itself is free of charge. Anybody can enter, but you have to sign up to enroll the course. And then the course, it looks like this. So actually this is my own page, and I'm a little bit embarrassed to show my progress, even though I am part of developer, but I haven't completed all. But again, you see that each course, and then once you complete, it says complete. And if it's in progress, it shows in progress, and it also shows the scores as well. For example, if you want to learn from module 1, which is cities and the marine plastic pollution, and then you click launch, and then you will see the explanation about each module. So each module starts with the module introduction, and the objectives comes later. The good things about this module is it has a lot of photos and images, graphs as well. So it can also, it contains as YouTube as well. So it's quite easy and fun to learn. Even though it's only English is the language that is used for this module, but since this is a digital basis, so I think it's easy to translate even online. So there are several sections under each module, and then you learn detail about these things. Yes, each module. And then at the end, there is a module summary, and it summarizes the important point of each module. And then there is also quiz. So if you pass 70% or up, then if you make the correct more than 70% correct answers, and then you can pass, and then you can go to the next module. So, and also there is references. So if you want to go into the detailed information about each module, and then you can click those references. And also there is also YouTube here. So this, as you see, this has a lot of information and very helpful to learn. So I really recommend all of you who are here to start enrolling this module. So I'm going to stop. Then Abigail, can you show again the presentation PowerPoint slides? Thank you. So since time is limited, I'm not really going into the detail, but just the surface of each module. So module 1 is talking about cities and the marine plastic pollution. So this explains a little bit about the plastic characteristics, what is plastic, how is it used, and also the main causes and consequences of plastic pollutions. Also the relationship between plastic and cities, and the global and the regional policy context of efforts to stop plastic pollutions. So it contains overall aspect of this total module. So it's quite important to learn, start from this module 1. Next, please. Module 2 is talking about the plastic value chain from source to sea. As you know, the plastic value chain is not only starting from the waste generation, it starts from the production. So this course, this module will explain about the from the production side, because the plastic, normal plastic, conventional plastic is made of the oil and also natural gas. And that will tell you how much it affects the environment as well when they produce the resin. And then that convert to the plastic, and then we consume a lot. Actually, we continue increasing the consumption of plastic. So therefore, the waste generation of plastic also increases, even though we try to reduce. Yes. And also this module explains a little bit about the influence of COVID-19, how COVID-19 influenced the recycling of plastic. So it's quite interesting to know that. Yes, and then it also touched upon the relationship with the SDG, how the plastic value chain link to each SDG indicator. Next, please. Module 3 is about the way to measure the plastic pollution. Janet already mentioned in her presentation, there are several methods to measure the plastic pollution. And then this module was developed by the University of Leeds and ISWA, and then they actually developed a couple of tools to measure the plastic pollution. In order to do some rapid assessment, probably the waste flow diagram could be the good method. But if you want to do the more comprehensive, more like accurate result, and then probably the plastic pollution calculator will be the appropriate tool. However, each tool has pros and cons, and if you want to seek for the more accurate result, then you will have to have the more detailed input data, which is quite challenging normally in developing countries. So yes, and then this module also touches upon the burning of the plastic waste that also create the pollution. So when we talk about plastic pollution, it's not only the plastic debris that is entering into the marine environment or retained on the environment, but also burning plastic also causes the pollution, air pollution as well. Thank you. Next, please. Module 4 is about the detecting the waste from land and space. So module 3 was about the modeling, how to measure or how to estimate the plastic pollution from the source, from the pathway and the sink. But this one is a little bit different. So we use, by using the satellite cameras or drones, or even integrating the AI technology, that we are trying to detect the plastic from the image, from the data in the images. So that's another method that we also applied in our project, Closing the Loop project. This explores the different methods to detect and classify the floating plastic in rivers and coastal waters. So that means that this identifies the snapshot of the plastic, the presence of the plastic in the environment. Yes. Next, please. Module 5. The before, probably you skipped module 5. Yes. Module 5, the importance of the involvement of informal sector. Yes, as you know, the role of informal sector, informal waste pickers in the field of solid waste management is quite important and quite large, I would say. However, most likely it's really difficult to get the data about them, how many plastic, how many recyclable materials they collect, and from where they bring, where they sell, or where they export. It's quite difficult to get such kind of data, but it's really important to get or even include them to get to know the data, also involve them in the level of planning. Because normally when you say formal sector, it's a government sector, the public sector who collect and transport the waste. But there is another sector which is informal, who is playing a big role to collect and also recycle the data, I mean the waste. So we have to understand the role and the importance of their actions so that we can integrate their activity in the formal sector, or find a way to collaborate together. So this module has been developed by WIEGO, and then it gives a quite good comprehensive information about the informal sector in the solid waste management. Next slide, please. Module 6 is about the other stakeholders. Actually, the informal stakeholder is also important, but at the same time, if you think about the plastic value chain, there are many other stakeholders who are involved. So there are public sectors, there are private sectors, there are civil society groups. So we have to involve all these sectors when we make planning, or when we implement, or when we even monitor the waste management, because the waste is generated by consumers. But before that, the product is produced by the manufacturers, and then the waste is after the generation, the waste is collected by the public sector as well as informal sector, and then they recycled by the private sector. So without involving all of the stakeholders, we are not able to solve the waste management issue. And if we want to reduce the waste generation, which is actually the biggest objective of the waste management, we won't be able to solve. So involvement of these all stakeholders is very, very important. Okay, next please. So the last module is about the local action planning to address marine plastic pollution. So the last module is the draws upon all the key learnings outcomes of the course and turns them into a practical action planning process. So it's talking about the collecting the baseline data. If the data from literature review is not enough, we have to complement with a field survey, and then those data the data we collected has to be processed using the model. Like I mentioned, for example, it could be the plastic pollution calculator or waste flow diagram or some other tool to estimate the level of plastic pollution. At the same time, we can also use the digital tool to identify or detect the plastic or by type or even the quantity. And then that data, together with the result of the analysis and governance aspect, which includes the policy review, also the stakeholder assessment or capacity assessment of the public sector, and also digital readiness. So together with those information, and we will develop the action plan, local action plan. So this module explains a step-by-step guide for policymakers and how to prioritize the intervention based on the local context. Yes, so thank you very much. Probably it's not enough to cover all the 7 modules. So for those who haven't studied taking the e-learning course, I strongly recommend to enroll and then learn, because it has more detail, much more comprehensive information in the course. Thank you very much. So you're going to watch the short video, I think. Yes, over to Janet.
Yes. Thank you so much, Miho. So yeah, everyone's encouraged to do it. Now we're going to do a deep dive into one of those modules. That was module 4, which is how to monitor plastic from land and space. So I'll show a quick video, and then the experts from that module will do an interactive session to show you how that's done. And again, feel free to add your questions in the chat. Okay, over to you, Abigail.
To put a stop to marine plastic pollution, we need to keep our eyes on it as it travels, from the land into the ocean. Start with using net sampling to trap and inspect plastic waste in your waterways. Then count the visible plastic floating on the surface. Communities can also help by using their smartphones to take photos of plastic pollution in their neighborhoods. But we don't have to only rely on people. Technology can help too. Installing cameras beneath bridges and on buildings overlooking waterways provides regular surveillance of plastic waste flows, while drones can capture bird's-eye view images of plastic hotspots across the city. And because of the way plastic absorbs light, you can even use satellites orbiting Earth to zoom in on wide sections of a river and monitor how much waste is clogging it up. Powerful algorithms trained by artificial intelligence are able to quickly detect the pieces of plastic in every image collected. And combining the data from all these sources creates an eye-opening overview. You'll see a moving map of plastic waste on your waterways, which means knowing precisely where it needs to be cleaned up so it stays out of the ocean. And by collecting the data, we can create a virtual twin of the ocean and work together to stop the plastic from reaching the ocean.
Okay, again, with thanks to Malati for voicing our videos. Okay, so without further ado, let's do a deep dive into how to monitor plastic waste from two of our favorite experts. We've got Dr. Lauren Bierman from the Plymouth Marine Lab. She's the expert of using satellites to find plastic pollution. And then we have Tim van Emmerik from Wageningen University, and he's our expert on detecting plastic from land, well, even if it's from a bridge or next to a river or something like that. So without further ado, let's start our interactive session. Over to you, Tim and Lauren.
Yeah, hi, good morning and good afternoon, everyone. And let me just quickly share my screen because I will start this 30-minute session that Lauren and I will offer you today. Let's see. Yeah, I hope you can see the screen, Janet and Lauren.
Yeah, we can see the screen.
Great.
Yep.
Yeah, so maybe time-wise, we have three short presentations or three things for you in mind in the coming 30 minutes. I will kick off with a short introduction to river plastic monitoring using field-based techniques. After that, Lauren will continue talking about observing plastic waste in rivers and the ocean from space. And after that, we will both do a final presentation with some examples of how you can actually use the methods that we'll talk about in actual case studies for monitoring plastics. Yeah, so for the next coming 10 minutes, I'll try to give a very brief overview of how you can measure and monitor river plastic waste or plastics in and around river systems. And I do that on behalf of the Wageningen University River Plastic Monitoring Team. Also, consisting of Louise, will be joining one of the breakout groups in the next session. What I'd like you to remember from today is that despite all the techniques and all the theories available, there's no silver bullets for river plastic monitoring. Every river, every city, every system requires for a tailor-made plan based on the local questions and the resources that are available. Last but not least, observations of plastics, monitoring plastics are absolutely key to closing the loop, and that's what we're interested in today and hopefully also in the near and far future. Before we dive into how we actually monitor plastics, I'd like to make clear what we talk about when we talk about plastics. When we talk about plastics and plastic waste, we talk about the macroplastics. So normally we divide plastic waste into small items or small particles smaller than half a centimeter, so microplastics, and everything larger than half a centimeter, which we call the macroplastics. And those are the plastics that we talk about today. Why do we focus on macroplastics? Because it is the macroplastics who cause so much damage to ecosystems, to flora and fauna, but also to human livelihood and economic activities. And despite all those very clear negative effects, we really know the least about these large plastic debris items, etc. What we work on at Wageningen University, and also in collaboration with our partners from the Plymouth Marine Laboratory and other partners around the world, is answering the following questions. Because it all starts with monitoring, it all starts with data, but we don't really know how to monitor plastics, right? So our first question is, how can you actually measure and monitor plastics in and around river systems consistently over time and space? And if you know how to do that, and if you are starting to collect your data, we can start answering the questions about where is actually all this plastic debris coming from? What are the sources of the plastics? Where do they accumulate? What are the sinks? What are the negative effects that they have on the system of interest? And what are the transport pathways? And the moment that we get insight into these mass fluxes and the plastic metabolism in river systems, we can think about how we can optimize or use those insights to optimize prevention and reduction strategies to achieve our aims and goals to reduce plastic waste in the environment. Now, plastic pollution research, plastic pollution action has been driven, of course, by the discovery of the garbage patches on the open ocean. And one of the key questions that was answered shortly after is, where is all this plastic debris coming from? And one of the main assumptions is that most of the plastic waste that we find in marine systems are land-based. And through river systems, they are collected and conveyed into the coastal area, and over time also make it into the open ocean. However, unlike common belief, recent research has shown that less than 2% of all the plastic waste that is entering the environment actually makes it into the ocean, meaning that more than 98% of the plastic waste remains somewhere behind, somewhere in terrestrial or riverine ecosystems. And that's exactly our interest. That is what we work on. We try to figure out what is happening with this 98% of plastic waste that doesn't make it into the ocean. And what we actually think is that rivers and river systems may act as plastic reservoirs, where plastics are accumulated maybe on riverbanks, sediments. They are floating, they are ingested by biota, they are deposited on riverbanks and floodplains and riparian vegetation. But the key is, of course, to measure it. Measure, monitor, because that shows where it is, so we can act on it. In the remainder of the talk, I would like to introduce a couple of monitoring methods or monitoring categories and show how we can use that to get insights into exactly the questions and answering that we're interested in. And in general, we can decide plastic monitoring methods in 5 categories, starting with collection and analysis, the visual counting relating to what Melati was saying before, the use of drones, the use of cameras, and finally the use of remote sensing. And especially the latter will be more elaborated by Laura in the next talk. Starting with collection, I think this is maybe the most straightforward and not always easiest thing to do, but it's what we instinctively maybe start with, right? We go to places where we find plastic waste, we take it with us and we bring it to the lab. On the picture, you see an example of the lab that we have in Wageningen. You can either go to specific places and for example, sample plastic using nets. That's what we call active sampling. But you can also go to places where plastics naturally accumulate. So, for example, in riverbanks or in litter traps, other types of infrastructure, etc. You take that, go to the lab, and that allows for either simple or very detailed analysis, thinking about what kind of category of litter do you find, what is the item category of the polymer type, what is the mass, what is the size, and based on all those insights, you can well, not only say something about where it's coming from, but also you can look at what the effect is of this plastic debris in the environment. Because as you can imagine, a straw or a plastic bag or a piece of foam may have a very different negative effect on the system. The second category of methods are the so-called visual counting or visual-based methods. And again, I think Melati already very nicely explained this, that if you don't have any tools available, you always have your own eyes. And it seems that your own eyes, our own eyes, are sometimes the most powerful tool to measure and quantify plastic pollution in and around river systems. So it's my personal favorite type of measurements. The nice thing about it is that everyone can do it. So it's something that I do myself. It's what we do with our team of PhD candidates and students and other colleagues. But we can also do this with school kids or local government employees or volunteers anywhere around the world, and it works. So you can do either visual counting from bridges, where you count the floating debris over time, allowing you to look at the fluxes of plastic over time. Nice example is here you see in the middle, bottom middle. So you can really see the seasonal dynamics of, for example, plastic debris floating in the Meuse here in the Netherlands. But you can also do this for riverbanks. So you can visit the riverbanks, you can mark out your sampling area, and you based on visual inspection, tally and categorize all the plastic debris you find there. And despite its, and maybe thanks to its simplicity, this really allows for a very powerful first-order estimate of the plastic transport, hotspot identification, and understanding how many plastic is being mobilized and transported through a specific system. Sometimes this is not possible because there's no bridge, or it's unsafe, or you're looking at a very large river, and in that case, also drones offer great opportunities for monitoring. So you can deploy your drone, you can take images or videos, as you see here displayed on the right. But also this comes with many practical constraints, because quite often there's legal context that doesn't allow flying for drones or flying with drones. Data processing is extremely time consuming. It's not as easy as it sounds sometimes. And we found that RGB, so normal photographs, are not very suitable for transferable artificial intelligence solutions, unfortunately. Good news is, and that's what we see here on the lower right, it's a paper by Louise Schijers will be doing that later. And you very clearly see that if you do it well, using drones really gives you the opportunity to pinpoint where plastic is present in a river. So you see the temporal variation, but you also see in space where plastic accumulates. And with that insight, we can act accordingly. Then there's cameras, as we saw in the movie as well. We did some work on this in Indonesia, where we applied cameras information with artificial intelligence for 5 rivers, and we trained an algorithm, and the performance was okay. It was really okay for individual rivers, but we also found it very difficult to just take an algorithm and apply it to a river somewhere else. It doesn't work. We really need way more, I guess, fundamental research and also manual data processing for the development of these really automatic monitoring systems. Finally, just a very brief statement on what we think is part of the future of monitoring, that relates to so-called hyper and multispectral sensing of plastics. Because there's more than just the light that we see. Lauren will tell you all about it, and we're trying to use all these other components of the light that are reacting to plastics and other types of debris to not only detect plastics, but also to separate plastics from other types of debris, to really distinguish between organic material, woody debris, boats, and plastic, of course. And the beautiful thing is that this doesn't only allow us to explore the potential of current satellite missions and see how we can use those to detect plastic from space, but it also allows us to really optimize future missions, to have targeted satellite missions really focus on detecting and monitoring plastics in rivers, in the ocean, and in terrestrial environments. I'll skip, well, very briefly, we have all these methods, and as said, it really depends on the local questions and the local context, how to apply those. So we have quite some projects all around the world, and you'll see that if you zoom in, every river has their own questions and also need their own individual suite of monitoring tools to answer those questions. So if you're in big rivers in Vietnam, like the Saigon and the Red River, that requires a completely different approach than the urban waterways in Accra in Ghana that we're studying. And in turn, if you're looking at a specific location, that also requires a very different approach than if you're, for example, looking at the whole river delta in the Netherlands like we're doing. Finally, some closing remarks. Why is monitoring so important, and why is monitoring around the world so important? I think we saw, unfortunately, a very clear example 2 weeks ago. Western Europe was hit by major floodings, once in a 100-year floods that were in the Rhine and the Meuse Basin. And well, next to all the devastation and the injuries and people dying, we also saw that these floods are mobilizing so much plastic waste through the rivers towards the oceans. And we were lucky enough that some of our team members go to the field and do a first monitoring effort during these floods. And we see that during these floods, there's 10 to 100 times more plastic flowing through the rivers, showing that these are really crucial events to quantify and to understand, because this is in the end, for a great part, what it's about. And if we don't measure it, we don't understand it, and we cannot prevent it or treat it. So with that, I'd like to end. There's no silver bullet for plastic monitoring. there's always a trade-off between local questions and local resources, but in the end of the day, observations are key to closing the loop. And with that, I'd like to thank you for your attention in these first 10 minutes, and I'd like to give the floor to Lauren for the next presentation on plastic observation from space.
Thanks, Tim. Just going to quickly share my screen. You should hopefully see the right screen. And thank you, Tim, for that perfect introduction. I'm going to talk to you a little bit about what I do, which is moving a little bit from sort of river systems into the coastal zone and even open ocean waters, where we're using high-resolution optical satellite imagery to detect plastics and other debris. And then, of course, the relevance to work that Tim and I are constantly collaborating on. And a lot of this is covered in the module for closing the loop on the e-learning content, but I've added in some new stuff for those of you who are attending both. So without further ado, if you'll give me a sec. Okay. So this is actually quite recent stuff. So it was only really last year for the first time that we were able to demonstrate in a way that was reproducible between different places all over the world that satellites could be used to detect floating marine macroplastics in patches. So this work only goes back to really, in terms of availability to the scientific community and abroad, since April 2020. But I want to say that it's only thanks to a program called the Copernicus program, which is a EU-funded program that gives us access to free satellite data. So I have access to this free data, you have access to this free data. Anyone on Earth who wants to be able to look at the data collected by all of these satellites under the Copernicus program is able to do so. And that's what I did. I don't have a lot of budget, and so I always use free data. But in this case, the free data is of high quality. So there's lots of different types of satellites, some of them measuring trace gases in the atmosphere, some of them measuring sea surface height or providing radar imagery. But the one I'm interested in for detection of plastic specifically, I need to find something in the Goldilocks zone. So first and foremost, it needs to be free. It needs to have high spatial resolution. So I need things at high focus so that I can see things. As Tim was saying, really our own eyes are the best way of detecting things, but my next best option is to see things with high focus from satellite. And then also, I need a satellite that's got high spectral resolution. And I'll explain what that means in a moment. But basically, the satellite that falls in that Goldilocks zone for me is Sentinel-2. And when I talk about spectral resolution, what I'm referring to really is the eyes of Sentinel-2. And it has very beautiful eyes. And I'll explain what that means through demonstration. So here is Da Nang, one of my favorite places to look at from space because it just always looks so beautiful and so interesting, and the watercolors are always so dynamic. But here we have a typical scene collected by Sentinel-2. You can see it's in focus, that's high spatial resolution. But also you might look at this and think, well, that's a bit hazy, and that you'd be right. And that's the contribution from the atmosphere. So you and I right now, we're going to do a very scientific process. We're going to remove the contribution of the atmosphere, and we're going to do an atmospheric correction. So I hope you're ready. There we go. And we have just applied an atmospheric correction, and we've removed the contribution of the atmosphere. And now it looks like if you were flying in space right now and you have really good vision, how you would see Da Nang. And that's because we've taken light in the red, the green, and the blue in the visible spectrum of light from Sentinel-2's eyes. And we've said, show us what the Earth looks like to our eyes, because we can see in the visible range. But Sentinel-2 can also see outside of that range into the near infrared and the shortwave infrared. And this is where things get interesting. So what I'm going to do is I'm going to ask you to focus on these areas over here, where you can see the white circles. Hopefully you can see them. I hope you can see my mouse. And now what I'm going to do is I'm going to say to Sentinel-2, please show us what you saw in the near infrared. And what I do there is you'll notice, hopefully, that where there was nothing but water, it looked very indistinct. You can now see lots of little white dots on the surface of the water. So if I go back and you go back to focusing over there, now that you know something's there, perhaps you can see it a bit clearer, but it is quite hard to see an indistinct. you'll notice that this very beautiful submesoscale feature, that's an eddy, disappears when we go to the near infrared. And that's because water absorbs very strongly in the near infrared. And anything floating on the surface of the water is thus going to reflect. And that's true for boats and it's true for plastic. So if we go back and do that again, you can now hopefully see all of these new features becoming visible to your eyes in the near infrared. And what I rely on in the coastal zone to be able to see things like this is something called submesoscale features, because even though we've got good focus from Sentinel-2, 10-meter resolution, at 10 meters resolution, we're unfortunately never going to be able to see a single plastic bottle in the way that Tim's drones can. But we rely on features like this called fronts or eddies, submesoscale features, to group the plastics together, because this is about a 10-meter pixel from Sentinel-2. Oh no, don't do that. Sorry. Finish. Oh, sorry. Let him finish so we can see that front again. So there you can see the front gathering those materials together into a patch. And now, no, why is it doing this? I'm so sorry. 1 second. Been on leave for a week. I seem to have forgotten how to do technology. But this is about the size of a Sentinel-2 pixel, that 10-meter resolution focus. And now you can see it's filled with debris, but it's composed of plant material and plastics and even a swimmer and the water itself. So like I said, we use the eyes of Sentinel-2, we use the information across the visible and the near infrared and shortwave infrared to get indices that allow us to see things floating on the surface of the water a little bit easier. So here's an example actually from my own work. This is the Isle of May, just off the east coast of Scotland. This is hazy, so let's do our scientific thing. We're going to apply our atmospheric correction. And now you can see this front really strongly just off the Isle of May. So we've just seen what fronts do. So I guess it's a bit of a spoiler alert of where you should be focusing from where I move into the near infrared and apply a floating debris index, which leverages the near infrared light. And now you can see what was invisible to us in the visible is now visible to us in the near infrared. And you can see debris floating along that whole front. And these little white objects over here are boats. And this is where I get really jealous of Tim's work, because I can't be on one of these boats. I can't go back in time and with the power of hindsight go, I need to be a passenger on this boat to actually see what this was. Because, you know, the ocean is a very dynamic and variable space. All sorts of things float on the surface of the water. Natural things like seaweed, even sea foam is really confounding. It can look a lot like plastic. Driftwood, pumice, and even life on the surface of the ocean, jellyfish and wind by the sea sailors, which I'm sort of obsessed with. So my real sort of obsession in life is to get a big slick of Velella and to see what they look like spectrally compared to plastic. But then, of course, we know that over time, natural things are becoming contaminated with plastics. And so this is often what I'm seeing mixed in with these natural things. And so that example in Scotland is there were, to what I could see, there were distinct pixels of plastics mixed in with seaweed there. But this is a nice example. This is where Tim, myself, and Louise are collaborating. This is a really good example of plastic being caught up in natural debris and actually being transported. So what I really love about this project called Plastic Plants, working on the Saigon River, is that we're combining all sorts of things. So we're using that thing I'm so jealous of from Tim, where we actually have people's eyes on the ground and on bridges doing in situ sampling. We're using free data from Sentinel-1, which is a radar satellite. And thanks to NOAA, who've gifted us free high resolution data from Worldview 3, even though this river is really broad, it's not, the Sentinel-2's focus is not quite fine scale enough for this work, but we have access to Worldview 3 data. And what you can see over here is hyacinth patches, and they're carrying plastics down to the ocean. And of course, the best thing to do if you want to stop ocean plastics is to stop river plastics. And this is the work that we're involved in at the moment. I also really like that because of the relevance. So not only do I get to benefit from having eyes on the ground, stopping things at source, and also getting to use a totally different range of satellites, we're also creating methods that are applicable to any sort of wide river on Earth where hyacinth, which is an invasive water plant, is carrying plastic. So we can hopefully learn and perfect in the Saigon, sorry, I lost signal for a second. Learn and perfect in the Saigon, and then help other countries all around the world where hyacinth is a problem and help them there. But of course, I make it sound quite easy, but as Tim said, and I think we're going to repeat this a lot, every single river in every single place is going to need a slightly different system, or a very different system. There's no silver bullet, there's no one size fits all. And so the work that we're doing over here, every single place here has its own method. So it is attuned to each place. I'm running out of time, but I just want to show you an example from Honduras Bay. This is work that was done by Katerina Kikaki, and I'm always just so in awe of the work that she did. But this is the Motagua River in Guatemala. And I'm just going to briefly show you that everything that you're seeing floating on the surface of this river is plastic. And so actually, to deal with the marine plastic issue in the Caribbean Sea, we need to be dealing, it's a river issue, not a marine issue. But thankfully, people on the ground there are, particularly Julio Perdomo, is putting booms out to catch those plastics. So I am going to end there, and I'm going to hand over to Tim now. I'll just replay that video, I think, so while Tim talks. And we're going to talk about work that we've been doing together, and show you our working, really, show you our notes, the back of the envelope work we've been doing.
Thanks, Lauren.
Yeah.
Shall I quickly share my screen for the workflow first, and then
yeah,
go
do
back
that.
To
that would be great. Yeah.
Yeah, and then maybe for the last example, we can go back to that slide. Yeah, thanks, Lauren. Yeah, so now we sort of opened you or introduced you to the world of plastic monitoring across scales and the different river systems. And the question, of course, is how can you use those tools and those insights to design a monitoring strategy for yourself, for the own river or the own system that you're interested in. And maybe you've seen that already in the module, but we had the opportunity to contribute to this by designing a sort of workflow for microplastic monitoring in and around water systems. So that could both include urban areas, also complete river systems, or the coastal zone. And what this workflow basically entails is a stepwise approach to really bring you from the question that you have to, in the end, the answer to that question, hopefully. And this workflow consists of 5 steps, starting always with the question. And in general, there's let's say, a subset of questions that are very relevant and popular. In the system we've been working, it's normally one of these, let's say, 5 main questions that are being asked, including what is the emission of, or what is the plastic emission of a certain river to the ocean? What are the 10 or 20 most common plastic items that you find in and around a river system? And what are the hotspots of plastic in time or in space? So are there specific areas, urban areas, or river systems where we find plastics? Are there specific hotspots in time? So meaning, are there specific moments in time where there's more or less plastic transport emission? And what are the explaining factors? Now, to answer those questions, it really depends on where you are in the world, what kind of river you're looking at, what the infrastructure is, where you are in space. So, for example, are you looking at a very narrow river in an urban area, maybe smaller than 100 meters wide, or are you looking at a more wider river, such as the Saigon River, the Mekong River, or even larger than that? And what is the infrastructure that's available? Are there safe bridges to do these simple visual counting measurements? Can you deploy nets? Are there opportunities for flying drones or installing cameras? And where are you located along the river? Are you somewhere upstream, or maybe somewhere close to the river mouth where you also have the influence of the tide? That leads to very different dynamics in terms of plastic transport, plastic settlement, and plastic mobilization. And the next step is looking at what are the local available resources, right? Because, of course, we want to measure everything always until the end of days, but it's very unlikely that you have the capacity or the resources to do that. So look at what is available. Are there any people available to observe with you? Do you have access to high-tech equipment or low-tech equipment, or no equipment at all, maybe? What is the measurement frequency that you need or can achieve given these circumstances? Now, once you know that, and once you made your trade-off between the local questions and resources, it's time to collect the data, and it's always good to think about how do you make sure that the data fits your question, right? So how do you normalize your data to standard units to make sure that you can compare measurements, maybe taken with different methods or at different times or at different rivers with each other. So how to make sure that it's consistent, not only in that place, but also consistent with the question that you're trying to answer. And then finally, if you have your data, if you can do your analysis, I think the key in the end is to make sure that your data and your answers are clearly visualized, that it's done in collaboration with the stakeholders, so with the stakeholders who are answering those questions or who need the answer to those questions, and do a final check at the end. So if you're done, if you have your data, if it's visualized and disseminated, does it actually answer the question that you asked at the beginning? Now, very quickly, I'd like to show how we applied this to 3 examples around the world: in the Netherlands, in Vietnam, and in Malaysia. And I think after that there will be a 4th example, Da Nang, by Lauren. But let's start with the first 3 that I have some slides for. So this is an example of a very urban area, the city of Leiden in the Netherlands. And the question in this specific case was, what are the most frequently found items? And do we find any hotspots in these urban areas? Thanks. In order to answer this question, we have to look at the system. And what we find is, in this particular case, we find a system consisting of very narrow pre-medieval channels. There's not much flow, and there's a lot of real constraints concerning the use of high-tech equipment. Also, like always, or like quite often, there was basically no funding. There was only low-tech methods available. So we really relied on the power of citizen science. Luckily, there's an app, the Crowdwater app, that is freely available and usable for everyone around the world. And the data is openly available for everyone to play with and analyze. But through the combination of the citizen science approach and the local momentum, we can start collecting data for actually quite some time already. We express the data in items per kilometer in the canals, and we could very nicely establish a top 10 of the most frequently found items. And that's what you see here in the bottom pictures. And actually, that is now leading to action, right? So in the city of Leiden, the municipal government is already taking action to prevent specific items from entering the urban water system. Another example is the case of the Saigon River in Vietnam. The question here was, what is the emission to the ocean? What is the seasonal cycle of the transport of the emission? And is there any relation or correlation with the local hydrology? With that, I mean the river discharge, river flow, or precipitation. Saigon River is about 300 meters wide. It runs through the big city of Ho Chi Minh City, and there is very strong tidal influence. Local available resources, well, we could pay one person for 1 year. We relied on low-tech methods, so visual counting and occasional net sampling. For the data, we could express the results in that for the data in items per hour or in mass per hour, and also the emissions in mass per year. But we could easily compare them to other assessments that were done before us. And we arrived at a very nice, it's not so nice in the end, top 20 of most frequently found items in the Saigon River. And yeah, this is very clear, I think, and this is also what is being used by some stakeholders for further research and hopefully also for further action. Final example is the River Klang, also one of the case studies in the Close the Loop project. And in this case, we were also interested in emission into the ocean, exploring the influence of the tides, and the question if there's a preferential transport side, so on the left or the right bank or in the middle. Again, here the River Klang drains the city of Kuala Lumpur at the end of or close to the river mouth. It's about 100 meters wide. There's strong tidal influence, and there are some safe bridges, but not everywhere. So what we could do, we could not afford a very long measurement campaign. We could only do very targeted measurement campaigns 1 week with some people and 1 drone. So it was a nice combination of both the low-tech citizen science / visual observation methods and the more high-tech methods using the drones. We could, in the end, report the data in items per hour and in items per square meter. which really gave insight in not only the cross-sectional profiles, so is there a preferential flow side, but also the very high frequency temporal dynamics. That's what you see here in the middle graph. You can really see that during the day, during some hours there was a very high flux and a lot of plastic flowing, and during some hours there was very low flux and sometimes even negative flux. So in these tidal systems, quite often you see that the plastic is actually moving into the land direction, so flowing back, let's say. And this is quite interesting because knowing that plastic is not directly flowing to the ocean, but it's actually sort of flowing back and forth for hours or days or maybe weeks or months, then it's also quite insightful in order to design a optimal collection tool. So you actually have multiple opportunities to fish the plastic out. So maybe that is a blessing in disguise. But you need to know that this is going on in your system, of course, stressing the importance of monitoring. I think with that, we can go back to you, Lauren, for the Da Nang case study, which is a little bit more elaborate. Oh, you're still mute.
Yeah, thanks, Tim. Yeah, I mean, that was those examples are awesome, and Tim shows them really neatly in this beautiful package. And I think what I like about what we're just going to end off with now is actually it's often not that neat at the drawing board. So Tim and I will sit with something like this for hours, and we will continuously check each other and we'll say, okay, what is the question? And this is one river. So Tim and I always talk about the fact that, you know, each place needs a different approach, but actually sometimes the same river can need a different approach depending on whether you're upstream, downstream, or in the actual coastal waters. And this is a really good example. So I'm going to take 1 minute because I think we're a little bit out of time. But basically, one of the things that when it comes to you and your area and work that you want to do when setting up your workflow, I think the key thing to start with is, what is your question? And then at the end, go, is the data I'm planning to collect and the results that I'm hoping to get out of this, does that answer the question I started out with? And you'll see that even though we're looking at the same river in Da Nang, whether we're upstream, downstream, or if we're just asking a slightly different question, we've collected different data. And so this is sort of Tim's domain where we're trying to find the hotspots of where plastic is actually entering the system. And this is way out of my comfort zone. It's way too high resolution. Oh no. And so there's no satellite role for me here. So this is where Tim has got people standing on bridges and doing riverbank sampling and bridge sampling. But also Tim talked about the mobile apps. That's becoming a really important tool for data collection. And in this particular example, mounted cameras as well. So, you know, for the whole first section of this work, I'm completely irrelevant. But that's okay. Satellite data is very specific, is very wonderful, but it is not always fit for purpose. And then Tim, I don't know if you know, we moved then on to the actual river part. And we established here, Tim, that it wasn't really safe to do net sampling, right? Because it was very tidal, it was around the monsoon. And so we established it was just safer to have people on bridges. That's a huge consideration. It's something that you have to consider when setting up your workflows, is actually if you are going to get people involved, whether they're volunteers or your students or your family, because you're really out of budget and you really need the help, you want to keep people safe. So that was a big consideration for us as well. And this was part of Closing the Loop program. We were supporting Japanese Space Agency here. They were doing excellent work. And one of the things that we were able to start to do is budget for some commercial satellite data because it's within quite a narrow river, right? And again, you'll notice that along each stage here, even though we're in the same area, our question is slightly different. And so our data is slightly different. And then last slide, really, this is my domain, really. This is where I sit more comfortably. So where Tim and I have this overlap. We again have people on riverbanks, but now we can start to use the freely available satellite data. And again, you know, we keep checking, does the data that we're collecting match the question that we originally asked? So I just wanted to show you how we constantly have this drawing board. We check it all the time. And we're constantly making sure that within our workflow, we're actually doing what we think we're doing or supposed to be doing. And this is what I like about this is it's constantly collaborative. It's constantly evolving. It's a living document that we change and update all the time. But this is what it looks like behind those beautiful slides that Tim showed, with the results, and it's all very neat. Actually, behind the scenes, we constantly are checking ourselves on this drawing board. So I'm just going to end there, and I want to say thank you for your attention. I'm going to leave Tim to say goodbye as well. But yeah, that's us.
Yeah, thanks, Lauren, and thank you all for listening to us. If you have any questions, feel free to reach out to us. I think our emails can be found on the presentations or on in the e-learning module, or we can type it here in the chat. And we look forward to further discussing with you in the breakout sessions afterwards. So thanks a lot.
Yeah, thanks.
And back to Janet, I think.
Yep. Okay. Thank you, Tim and Lauren. You know, even though I've seen the presentations in the e-learning, I always learn something new when I do what you present. So thank you again. So, you know, I think their work's really interesting because what we're trying to work at in the UN is whether we can move to a digital twin of the ocean where we can see that plastic waste. So if there are efforts to measure plastic pollution in Da Nang or Saigon or Honduras, all of that information could come to one compatible platform so we could see and compare. So I think efforts like this are really important. And the last little bit on the data flow, data workflow, where you start with those policy questions and then design the monitoring system based on them. I think that's something we found really useful and important under closing the loop, because you might sort of hear about a cool technology like drones or whatever, and it may not actually be fit for purpose for your policy question or for the city that you're working with. So thanks for that. And again, you can learn more in the e-learning course. Okay, so we have learned how to measure the plastic pollution. We've learned how to monitor plastic pollution. And in this final part, before we go into the breakouts, and you have the chance to interact with Tim and Lauren, myself, and two other colleagues on the policy side in the breakouts after this. But before that, we're going to look at what's it look like to manage the plastic pollution. So at the very start, we heard from Takayuki about the international policy cooperation, but we're now going to zoom in at what does national level policy on plastic pollution look like? And that will be the presentation from the Vietnam Institute of Seas and Islands. So Dr. Pham Van Hue, who is the Deputy Head of Division of Marine Environmental and Ecological Research, will talk about the national level. And then we will talk about local level, because as I said at the beginning, a lot of plastic waste management happens within cities. So we need to have that corresponding action at that city level, and that the presentation will be from Ms. Nguyen Thi Hien from IUCN Vietnam. So let's start with Dr. Pham from VISI to start with the national level management. Over to you, Dr. Pham.
Yeah, thank you very much. I am Pham Van Hue from the Vietnam Institute of Sea and Island. On behalf of Vietnam Administration of Sea and Island, I'm very sorry to thank you to inviting me as the speaker. Today, I would like to share my presentation with the title of Marine Management and Research of Marine Plastic in Vietnam. So first of all, I would like to overview about the plastic pollution in Vietnam. As you know, from the research, global research, shows that Vietnam is the top 4 country most pollute plastic waste to the sea in the world. And the plastic use increased from the 3.8 kilogram per capita in 1990 to the 81 kilogram per capita in 2019. And only about 15% of country plastic waste is recycled, and more than half the equivalent to the 3.6 million tons per year is managed. And to reduce the marine plastic debris in Vietnam, the government approved the National Action Plan on the Marine Plastic Debris Management by the 2030. From this, we have the 5 targets until the 2025 and 2030. The first is to reduce the plastic debris in the sea and in the ocean. And second, we would like to we want to connect the fishing gear and other related to fishery. And the third, we want to prevent the use of single-use plastic product. And we hope that until the 2030, the marine plastic protects area have no the plastic debris. And to the building the baseline data on the marine plastic debris, we want to every 5 years to assess the state of marine plastic debris in the 11 main river basin and the 12 insular district. And to complete the national action plan on the marine plastic debris, we propose a 5 tasks and a solution as a sample: pricing, availability, treatment, controlling, cooperation and research, and policy. And one of these I want to emphasize is cooperation research on the marine plastic debris, the pollution risk and the hazard, and the impact of plastic debris episode on the microplastic on the marine ecosystem should be assessed, and solution for mitigation of plastic debris impact should be done. So besides the approved national action plan on marine plastic debris, Vietnam has a good international cooperation in mitigation of marine plastic debris. Vietnam propose initiative in arresting the plastic pollution and promote the circular economic development in Vietnam. And we now developing an international center on the marine plastic debris in Vietnam. Besides, we cooperate with the organization and the countries such as Japan on supporting the equipment for the research on marine plastic debris, and we participate in global action plan on global plastic action partnership with the supporting of WWF. So I will move to the next slide for the review the research on the marine plastic in Vietnam from one research from the university in Singapore. They show that it's very lack of international publication on the marine plastic debris in Vietnam. So you can see in the two figures, so that we have the more than under the 4 publication on the microplastic and the macroplastic, and the almost of the plastic research focus on the situation of plastic debris in the beach estuary, and a very few study have been done on the hazard and the impact of plastic debris, particularly in microplastic. So this is some overview of the plastic in Vietnam, and we have one public paper from the Dr. Tim Van Emerick, and recent public from the Dr. Emily Seddy for the research on microplastic in the sea. And this is two research from my team for the research on the microplastic in the Thailand flood sediment and the surface sediment in the mangrove forest. So from the last year, we have a cooperation with Dr. Miss from the Plymouth University for the using the Earth observation in the reef flow that so that we use same the location with the Da Nang city, same that Dr. Noren Briaman that present. So besides from our institute, Vietnam Institute of Sea and Island, we cooperate with other countries such as Japan in using the Newton net to the monitoring the microplastic in the river mouth of in the northern Vietnam. Besides, we try to counting the microplastic debris in the beach and analyze in the laboratory. Yeah, from my research, I have the connecting the sediment core in the mangrove forest and analyze how the contamination of the microplastic in the sediment and accounting and so that there are many microplastic occur in the sediment in the mangrove in Vietnam. So from my review on the management and research on marine plastic in Vietnam, I have the 4 recommendations for future research. The first, to implementation. We should implementation of regional action plan on marine plastic debris on the coastal province. The second, for establish a data baseline. We should investigate and monitor to assess the state of marine plastic debris in the coastal Vietnam and establish a national database for marine plastic debris. Continue with the international cooperation. We hope that in the future we can establish and operate the international center for marine plastic debris and joining the global treaty to combat the marine plastic pollution. For the future science and technology, I think we should innovative research methodology regarding to plastic characteristics related to the ecological and the health impact. And second, we need to conduct the research on the hazard and impact of plastic debris particulate in microplastic. And finally, due to the COVID-19 pandemic, so that there are many single-use plastic and the plastic from the so that we should assessing the marine plastic pollution from the COVID-19 pandemic in the coastal region. That's all of my presentation. Thank you so much for your attention.
Thank you so much. Okay, so there's an overview of how this looks at the national level. So identifying those priorities by coordinating some research and then translating that into national policy. What the next step is to translate that into the local policy. So we're very happy to have Hien from IUCN. She's been working with us under Closing the Loop to support Da Nang in developing their city action plan, which was launched last week. So over to you, Hien.
Thank you, Janet. Just give me a while to open the slides. Can you hear me well?
I can hear perfectly.
Okay. It seems something wrong with my screen. I can you see the screen just share now by me?
So I could see the title slide, yeah. And the next, yeah, the second slide.
Okay. So good afternoon, and also thanks to Janet for inviting me to join the workshop, and also nice introduction about myself. I am Hien from IUCN Vietnam, and I am also part of the project team to undertake the Close the Loop project that Janet just shared with you and introduced you at the beginning of the workshop. We have already listened to the previous presenters about the importance of the monitoring or measuring and also monitoring the plastic waste pollution as a basis for turning them into the policy. And today I would like to also to share with you a case study on how the scientific evidence is translated into the policy at the local level in Da Nang City. So we have already heard Janet talk about the close the loop and also the cities that has been selected to participate in the project. So I won't touch upon that anymore. But just to show, just to note that among many cities in Vietnam, after the National Action Plan of the Marine Litter issued into late 2019, many cities in Vietnam has issued or accordingly issued their city action plan, but without doing any proper or comprehensive data analysis. So I can say that Da Nang city, thanks to the Close the Loop project, is the pioneer city that has been conducting quite good baseline research and study as a basis for the city action plan. Yeah, so for this slide, we'll skip it because Janet already talked about it. In order to conduct the baseline for the assessment, initial assessment in Da Nang, we use both the inputs from the secondary data and also the primary data. For the secondary data, we have one locally based consultant in Da Nang, and then he supported us with collecting all the information and also the sampling work. For the primary data about the plastic waste composition as a primary data, and for the secondary data, he's also supported us with connecting and liaising with the local department in the city of Da Nang to get information about all the relevant data related to the topography, demography, land use, water path, and also waste management system there in Da Nang. And then and then we also have among the project team, we also transfer, or let's say like discuss or share the data with the University of Leeds, who owns the PPC, the plastic pollution calculator toolkit, and then supported us with analyzing the data, and then and supporting us with finding out the output data about the plastic waste composition, about the waste to the environment, the amount of waste to the environment, or also the waste generation, as well as all the data in terms of the urban burning and also uncollected waste, and also the possible plastic waste transportation to the waterways. And then by doing this, applying this PPC methods, what we can do, what bring us the benefits are supporting us with the identifying the locations and the conditions where the plastic may leak to the environment, and also to allow the city to suggest very specific area specific social and technical interventions and policy action. And along with that, our project team also conduct a review of the governance aspect in terms of the plastic waste management in Da Nang City. We review the current waste problems and what are the current plastic waste management practices there, and also the institution responsible for the waste management, and trying to look at three pillars. One is the stakeholder and the policy and regulations in place, and also the capacity of the city, whether or not they can control or enforce the policy. And we also look at, the awareness and also the coordination among the stakeholders. And for the digital tools, I think Janet already mentioned, and just to note that, in the coming time, this digital tool will be introduced and also applied in the coming time in Da Nang to support them with the implementation of, one of the activities under the action plan. And from the data coming out from the baseline assessment, we try to connect the baseline data with the actions. So as this, Janet's slide already showed you, some of the figures in here. These are, some of the highlight from the baseline data. Like the figures show you about the plastic waste management in Da Nang, and the mismanaged percentage of the waste, about accounting for 8% out of the total plastic waste generated. And also as Janet said, out of the 8% of the mismanaged plastic waste, there is a 1.3% that leaks to the to the ocean, and although the percentage is a 1.3, but it is equivalent to like about 1,000 ton per year leakage. And if you can imagine, like how much of the plastic bag accumulating to make up like a 100,000 ton per year, that will be like millions of the plastic waste. And next figures is about the plastic waste composition, in which Janet already mentioned that the plastic bags are the most popularly or the most commonly found items in the composition. And next is the plastic film. And also in the composition of the plastic emissions to the environment, we also see that plastic bags and also plastic film are the two major sources. For the plastic waste generation, we also, from the baseline assessment, we also identify, the household, the single family dwelling, and also offices, and also transportation and storage are the activities that generate more plastic waste. And for the plastic pathway, also 49% of the plastic waste are dumped to the water, and 40 remains in the 40% are from the land to the water. So and lastly is about the key source for the plastic pollutions. 4 key sources of the plastic pollutions can be seen. The letters is are a bit small, very hard for you to read. But then these are the top 4 sources include the littered waste, uncollected waste that are litter like freely or illegally inland, and fly tip waste, and also the waste that has been disposed but waiting for collection, also the major source for the plastic pollutions. And from these baseline data, the city action planning has been connected very well with the baseline the baseline assessment output. 4 of the prioritized actions that include first group of the group of action that are the public awareness raising, just to change the behavior to reduce single-use plastic of the public and household, and also the retailer, school and officers, and also even the fishermen, and also wet market and supermarket in the city. And second group, under the first group, there are 9 actions that are listed as the prioritized tasks that will be undertaken. And the second group of the action are on implementing the targeted action to reduce plastic waste generation and leakage in the city. And under this group, there are 7 actions. And these 7 actions are, targeted on encouraging the waste segregation and recycling, and or no single-use plastic in the market or supermarket or retailer, schools, or in the agriculture production activities, as well as tourism and industrial factories. The third group is to prevent the marine debris from land and also on the sea. And under this group, there are 9 actions, and those activities will focus more on business to use alternative product and to control the land source pollutions by monitoring, supervising and investigating in the activities inland, just to prevent the leakage of the plastic waste into the environment, and also to encourage the product and the use of the recyclable plastics, and also call for the investment and investment and resources for addressing for the investment on the recycling and also investment on the circular economy. And last group of the actions are the international cooperation in scientific research and application, and as well as a technology transfer on the ocean plastic waste. So this is more on mobilizing the resources on the from the different organizations, including international and also local NGO, on joining the effort to deal with the plastic waste issue, and also to implement the ongoing or the upcoming project on plastic waste that also undertaken by different organizations, and also to conduct the research and technology transfer on the waste reduction and also treating the waste. So these are the the major group of the activities that under the action plan that has been approved in Da Nang. So I think that covers what what I would like to share with you today about using the output or the baseline assessment data to translate it into the local policy action. And in the coming time, ESCAP is going to also to be with the local government to also mobilizing the investment and also the resources from many other organizations who share the common interest in addressing the plastic issues in Da Nang, and then support Da Nang or as a local government to implement the approved city action plan. Yeah, I think that's what I would like to say. And back to you, Janet. Thank you for listening.
Thanks very much, Hien. So I'll put the link to the action plan in the chat so that you can actually see the different measures under those 4 categories that Hien mentioned in more detail. So what you'll see, the correspondence between those results that she shared, is that because plastic bags were so dominant in the plastic pollution, there's actually a whole section and a whole set of measures related to the reduction of the use of plastic bags, right? Not only to an appeal to citizens, but also targeting schools, targeting markets, and other users of plastic bags. And then in other sections, they have more targeted actions towards providing alternatives to plastic bags. And then there's another section on strengthening collection, etc. So thank you so much, Hien. I did forget to play the. Thank you so much. Okay, so okay, we're going to do 3 things now. We're going to play a real quick animation on how to manage plastic waste. Then we're going to put you in your breakout groups, and we're going to have a 15-minute break. So please do not exit the Zoom during the break, because there won't be a room to come back to, because you'll already be placed into your breakout groups. So best to just leave your computers as they are and get a stretch, like take a breath, as Malati recommended. And then 15 minutes after I play this video, we'll start the breakout groups. There are 3 breakout groups. One is more focused on coastal ecosystems. That's with Lauren and myself. Another one is based on river ecosystems. That's with Tim and Louise. And the last one is on policies, which is by the UN colleagues, Alex and Andrew, who you'll meet there. Okay, so without further ado, I'm just going to play the video on managing plastic waste, and then we'll enter into the 15-minute break.
Over half of all marine plastic comes from urban areas. So to protect our oceans, every city needs to create a unique action plan that tackles its specific issues. By measuring your plastic pollution, you know what product, which sector, and where it originated. With monitoring, you've discovered your baseline and are tracking the hotspots. Now you're ready to explore solutions that target the products, sectors, and locations you've identified. Consult with people directly involved in the supply chain, particularly the informal sector, who are crucial for collection because they could have insights you need for effective initiatives. You can find out what will be adhered to and enforced by asking citizens and fellow policymakers for their opinion. To begin, focus on reducing single-use plastic in your city. Try restricting single-use plastic bags while incentivizing alternatives. Next, adopt a circular economy approach to plastic by improving the quality of reusable materials and exploring ways of designing out plastic altogether. Assign responsibility to producers to support collection and recycling, and provide finance to improve waste collection methods wherever possible. You can also develop a more competitive recycling market by incentivizing recycling take-up and increasing demand for recycled plastics. With the right long-lasting measures put in place, we can successfully reduce plastic pollution in our oceans. So start working on your local action plan to keep plastics out of our oceans.
Okay, just a quick animation on managing plastic waste. So Rose has asked for Malaysia. I think I'll check on whether there's one at the national level for Malaysia. We're going to work on the action plan for Kuala Lumpur and the baseline report and the plastic pollution calculator results for Kuala Lumpur should be available in a couple of months. Okay, and I can see there's quite a few messages in the chat box that I'll leave there. Okay, so now it's time for a 15-minute break. We're going to take a break until 1:30, unless you're in India time zone, then it'll be to the hour, but it'll be about 13 minutes long. And then when you come back, you'll already be assigned to your breakout room for an interactive discussion with some of the presenters here. So without further ado, please go and stretch your legs, take a break, and we'll see you in about 13 minutes.